Hi everyone. Today we're going to learn about the probability topic of expected value. So expected value, in the briefest of definitions, is what we expect to happen based on all of the outcomes and the probability of those outcomes. So let's look at this game. So you get the opportunity to roll a fair six-sided die. If you roll a 1 or a 2, you get $15. A 3 or 4, you get $20. And if you roll a 5 or 6, you lose $30. So would we want to play this game? That's the ultimate goal, is to figure that out. Is it a good game or is it a bad game? So the pro is four ways to win. I can win with a 1, a 2, a 3, or 4. And a 5 or 6 are losers. So more winners than losers. But the con is if I lose more than I'd win. So today we're going to figure out, using expected value, should I, on average, do I win or do I lose? So what expected value is, it's the average outcome. So it's kind of like a weighted average where you take the sum of the outcome times the probability of that outcome, plus another outcome times the probability of that outcome. And you do that for all of the probabilities, you add them up, and the expected value is closest to whatever is weighted the heaviest. We're going to see that in an example. So it's the average outcome. If I were going to do an infinite amount of trials, what should be expected on any single outcome? So we're going to have a carnival game. You pay $1, you spin the wheel 3 times. If you get even, you win. Otherwise, you lose. So we got to figure out the expected value of this game. So first off, we have to figure out our events. So at the end of the game, in this case, we could either win or we can lose. And if I win, I'm going to get $3 because I paid 1 and I get 4 back, so I'm up $3. Lose, I just lose $1. I lose what I paid, and then I'm done. Next, I have to figure out the probability of each event. Now, since each one of these trials is independent, the winning I need to figure out is even, even, even. So half for win on the first try, half probability win on the second try, half win on the third try. So the probability of spinning 3 evens in a row is 1 out of 8. Now, in this case, lose is the complement, so it's anything else happens. Could have 2 evens and an odd, or 3 odds, or anything besides 3 evens. It would be 7/8. So now expected value means I'm going to take the event and multiply it by the probability of it occurring. So I'll take 3 and multiply by 1/8. And I'll take -1 and multiply it by 7/8. And I'm going to add them together and see what happens. So I add them together and get -5/8. Since this is money, I'm probably going to want to convert it to a decimal. So it's about 63 cents. And it's negative, which means our expected value is that we lose 63 cents on average when we play. Now, you can't lose exactly 63 cents. A lot of times you're going to lose the dollar, and then one out of every 8 times you'll win $3. So overall, this is not a good game because the expected value is negative. So that would tell us that we probably should not play this game for the probability side. And that's how expected value works.